So here we're looking at corresponding angles, and corresponding angles occur just like our alternate angles. We need two parallel lines. They need to be intersected by a third line, but this time they are going to happen when we look at the F shape that is created. So I've got one parallel line and another parallel line, as we've shown there. So they don't meet, I've just simply moved them up. And so what we're going to do is we're going to look at the fact that if we were to take this angle here and just travel it up that line, we find that actually they are exactly the same. Okay, so looking at that, that's the fact that we are going to abuse here. So that angle down the bottom, the angle slightly further up, both of them there in red, are the same as each other. So sometimes when we're looking at them, they're not always obvious. So what we need to make sure is we need to make sure, first of all, that we can spot where they are. So I've got two parallel lines, a third line that cuts through them. And again, one of the most important things we need to remember here is that they have to have two parallel lines. Okay, if two of the lines are not parallel, then we cannot use this fact to help us. Okay, so there is one of my F shapes. So hopefully we can see it a little bit better now. I've got two parallel lines and this line that kind of cuts between them. So that angle and that angle, one down the bottom, one up the top, I don't know if you can see my little pointer or not, I don't think you can, are the same. But remember, just like our alternate angles, our shape can go the other way. Okay, and so our F shape can go backwards as well. Same thing holds true. Angle down the bottom, angle at the top are the same. Looking at this shape again, it's a little bit more complicated looking, but we're looking for wherever these F's are. So I've got an F shape there. So those two angles are the same. I've got an F shape there. So those two angles are the same. And I've got an F shape there. So those two angles are the same. And that's one of the first things we need to do. Before we start rushing in and trying to work out anything, we need to start working out where our similar angles are. Which angles are the same and which ones are different. How much do we actually need to work out here? So remember, our corresponding angles look like these shapes, but they must have parallel lines. So all these different shapes, all these different kind of rotations of an F type shape. Okay, we need to watch out for any of them, but they need to have the two parallel lines. So looking at this one, and again, we can see that there are two parallel lines because the line from R along to S at the top and Q along to T in the middle, they've both got that same little arrow in them, so we can tell they're heading in the same direction. So because they have that, we know that the angle at R and the angle at Q have to be the same. So they are both 125 degrees. If we look at this one, again, we've got this kind of upside down F shape. So we've got 91 degrees at angle JKN, and we want to find the size of angle JLM, so the one down the bottom corner. And so because we know the top one is 91 degrees, we know that bottom one must also be 91 degrees. If we look at this next bit here, we want to find all the missing angles. Okay, so not just the one that's similar, we want to find the other one as well. So we're looking for this F shape, so there it is. Okay, I've got my two parallel lines, I've got the other line there as well. And so because that is the case, I know that one slightly further down must also be 82 degrees. What I'm going to do is I want to find that other angle. So I'm going to ignore the bit at the top just now. And what I've got there is I've got a straight line. Okay, so I've actually got, what I should have, are two supplementary angles. And so I know then that 180 minus 82 gives me this missing angle. So actually 180 minus 82 is 98 degrees, and so that's my missing angle that I've got up the top there. Okay, this one, again, this is another instance where we're looking at this F shape, but it's not actually obvious. And sometimes what we need to do is we need to take this line that's intersecting our two parallel lines, and we need to just extend it a little bit before we can see that F shape. When we do so, we extend it just with that wee dotted line, that dashed line, just so that we can see that that's not actually part of the shape we started with, but we added that in to help make a little bit more sense out of the shape. Okay, and now we've got our F shape. So what that means though is that angle there is 46, but that angle is out with my shape, so that's not actually an angle I was looking for. I want the angle next to it. I want angle D. Okay, but again, remembering that what I've got are two supplementary angles. So I've got D and 46 there on either side of this straight line. So D plus 46 needs to give me 180 degrees. So 180 minus 46 gives me this missing angle D, and so D must be 134 degrees. Okay, extending this into a bearings context, and we're going to look at scale drawings and bearings in our next topic, so we might as well cover this just now. So if the bearing of A from B is 68 degrees, okay, as in we've gone from B up to A at 68 degrees, find the bearing of B from A. Okay, and so we're heading backwards this time. And what we'll look at in a little bit more detail then is that our bearings are always measured clockwise from north. So I need to draw in my north line because they're both heading north. They should both be parallel to each other. So the north line at B and the north line at A should both be heading up straight to the top of my page. The angle I want to find is this red one here. So what I'm going to do is I'm going to extend my shape a little bit so that I can create my F shape, and in doing so I know 68 degrees is what's missing there from my north line round to my dashed line. What I want to know is I want to know the bit underneath it, and because that is a straight line, I know that that angle underneath is 180 degrees, and so what I'm actually going to end up doing is I'm going to add 180 to 68 degrees, and that gives me 248 degrees altogether. So the bearing going back of B from A is 248 degrees. So again, we'll look at bearings a little bit more later, as long as we're making sure we're happy with where these angles are coming from. Okay, similarly, if the bearing of M from P is 125 degrees, we want to find the bearing of P from M. So again, same principle, we're just going to head back the way. So the first thing we're going to do is we're going to draw in our north line. Okay, because it's another north line, it's parallel to the one that's already there, and just to help, okay, that's the angle we're looking for, and just to help with my drawing, I'm going to extend my line down a little bit. Okay, again, we'll squint our head slightly to the left, we can see this F shape that we are looking for. Okay, now that I've got that F shape, I know that that bit missing on the top is 125 degrees. I know that the straight line is 180 degrees, and so my red angle that's missing is going to be 180 plus 125, and that is 305 degrees altogether.